This
So friends,
conference will now be
what we have to
recorded.
do today is we have to see this data structure called undirected or directed weighted graph, right? So we will be creating a graph data structure once again, but at this time what you will see is on the edges of the graph we have something known as one integral parameter, one number, right? It can be integral, it can be float. So this is known as the weight, right? So you consider that from node 0 to node 1, when I'm talking this weight 4, you can just consider that this is a location A and this is a location B. For example, your home or your any office place, right, to some other destination. So you have this distance D, let it be in kilometers or in miles, right? So in a directed or an undirected weighted graph, what we have is we have the weights associated with the edges. Now, if you will look forward to this graph, so in the edge list, you got 0, 1. So 0 to 1 edge has a weight of 4. 0 to 2 is weight 4. 1 to 2 is weight 2. So every particular edge is going to have one weight associated with it along with the vertex. So there's 0 and 1, right? These are the vertices or the nodes of your graph, right? And the edge which connects to them is basically having a weight. And your adjacency list is going to be a list where 0 has 1, 2, 3, and 4. So 0 has this 1, 2, 3, and 4 as its adjacent neighbors. And now we even have the weight associated written with them. So today we have to write and code the same data structure, right? So first of all, I would like to get an acknowledgement from all of you in case this part is clear to everyone. What we have to code, can I get a smiley from all of you? So Gurlibleen, Lavesh, Shivam, Tejeshwar, guys, good to go? All right, guys. So let's try to code the same. And I'm going to just take one small screenshot for this fellow. So this is this undirected weighted graph with this edge list. So let us write this new Python file called session 33. So I'm going to use our previous graph algorithm, right? So this is the previous graph algorithm which we created. So we have this BFS and DFS involved, but I'll consider one more graph structure. So we're going to consider this. Just give me a moment. All right. So guys, this Facebook example, right? So we're gonna replicate this Facebook example, but not as in the use case with the Facebook. So we'll try to write a basic graph first of all, and thereafter we'll try to move in further. All right, so let me come here. So I need to have a graph where these vertices are going to be your dictionaries, right? And in case while you will add the edge, so you have these vertices v1 and v2. So if v1 not in the vertices, you add this a vertex in this dictionary, right? And so is the other use case, right? So to begin more with this graph, I will first of all write a class called edge and define a constructor where I'm going to take an input as vertex 1, vertex 2, and the weight associated with the edge, right? So guys, you say self dot vertex 1 is the vertex 1, then self dot vertex 2, and then lastly we have this weight. So this is how we represent an edge, and I'm gonna say define get the edge details. So I'll return back this string here. So it's a bidirectional graph. It's an undirected graph which we are going to make. So this is your edge, right? This is how your edge will look like. Dot format self dot vertex 1 comma self dot vertex 2, and then lastly we'll say self dot weight. So this is what we got as in our edge, right? Now let me define this function main. So in the main, I will write few edges first of all. Okay, so we'll follow this structure here. If you see this edge list, so you got 0, 1, 4, 0, 2, 4, 0, 3, 6, so on and so forth, right? So these are all the edges. I'm going to create these, objects of my edges. So it will contain vertex 1, vertex 2, and the weight associated on that particular edge. So coming here, I will say edge 1 is going to be an edge, right, which is from your 0 to 1 with weight as 4. So on and so forth, will write all the edges. So these are the edges, right? So I think there are 7 of them. So from 0 till 6, I can just use the same terminology so that you should not be confused. So let's say this is edge 0, right? So let me just write down the numbers 0, 2, 4, 0, 3, 6. Then 0, 4 is 6, 1, 2 is 2. 1 and 2 is 6. Sorry, 1 and 2 is 2. 2 and 3 is 8. And the last one is your 3 and 4, which is 9. So this is what we got as your edges, guys, right? So these are your 7 edges which we have to add, right, in your graph. So of course, if you want, you can create a list of edges as well, right? So edges may be a list where you have this edge 0, edge 1, so on and so forth. You have these other edges. So we'll keep on adding them. Right, so here we are with the list of edges, right? So let us see for edge in edges, print edge dot get the edge details. So running this program now, so these are the edges, right? So you got this 0, to 4, 0 to 4 with so we have here, let us see this. So 0 to 1 and 0 to, so I think I have written in a wrong way here. So very quickly we'll rectify that. The second parameter is your weight and the third parameter is your vertex 2. So now I'm going to run this code. So 0 to 1, 0 to 2, 0 to 3, 0 to 4, 1 to 2, 2 to 3 and 3 to 4, right? So the same edge list, if you can see here. So this is your edge list, right? 0, 1, you have the weight of 4, 0, 2, you have the weight of 4, so on and so forth. 3 and 4, you have the weight of 9. So can I get a smiley? So this is how you can create your edge object. You can have a list of edges which you would like to add in your graph. Now edge contains the information with respect to your vertices and the weight. Now in my graph, if you create this graph over here, so let us say we write a graph as in this graph. The moment you create a graph, you have a dictionary of vertices which you have created. But this dictionary of vertices is empty, right? So if I try to write a function which says define print graph, so I'll just come up here and say print me, let us say vertices in graph. This goes like your length of self dot vertices as of now, right? As of now, this is what I have done. Just give me a moment, something all right. So let's come here and say your graph dot print the graph, right? So when you run the program, you find that vertices in the graph is 0, right? So number of vertices in graph, so they come out to be 0 for us. The reason is you haven't added any edge in your graph as of now. So now I'm gonna say graph dot add the edge. But guys, this time this add edge function should not take vertex 1 and vertex 2 as input. It should directly take an edge as input, right? Now what I'm gonna do is, if edge dot vertex 1 not in the vertices, so you add this vertex 1 which is in the edge. So your edge dot vertex 1 will be added in the graph, and this is going to have an empty list, right? Same way, in case your edge is going to have this vertex 2 not available in the vertices, so we'll add this vertex 2 and will maintain its adjacency list as an empty list, right? So you added an edge, but when you are adding an edge, you're not maintaining as of now the adjacent vertices. You are only adding the vertices in this graph. So now what I'm gonna do is, so rather than doing a print command here, so I'll just write for edge in edges graph dot add the edge, right? So you add all these edges, and remember this dictionary which you have, I mean this list you have created here, so it can be even created in this manner. So it's up to you how you're gonna work on the part of your object construction, right? It is up to you how you're gonna maintain this part, right? Whatever the way you are more convenient. So of course this is one more better way to create your list, right, of edges. So I'm writing this loop here. So once I will finish my loop, I will try to come out of the loop and say graph dot print the graph. So let us see what happens after you executed your add edge function. So what we see is, it says now the number of vertices in graph is 5. So let us come here. and see how many vertices we got. So we got this 0, 1, 2, 3, and 4, right? So total 5 vertices from 0 to 4. So these 5 vertices, 0 to 4, they are available in my graph, right? And if you want to print their adjacency list, so guys, I want to print the adjacency list of my graph. So I'm gonna say keys is self dot vertices dot keys, right? So you get all the keys. So once you have got your keys, then I can say for key in keys, you are iterating in the dictionary keys. So you got this dictionary key. Now I'm just going to come up and say print me self dot vertices of the key. So when you run the program, right, and I can do one more thing here. Yeah, let's try to print that first. So what you see is that there are these 5 empty lists, right? So these are all empty because we added only the vertices, but we didn't add your you can say this part of adjacent vertices in their list, right? So you got this add edge function working. You added the vertices, but you didn't add your uh, adjacent vertex, right? So coming here, when I was printing my graph, so I'll just come here and say print me. So I'm just gonna say this adjacency list for vertex comma key, right? So we'll print and we'll see what is this output which is coming up for us. So what we see is for this vertex 0, it's an empty list, 1 empty, 2 empty, 3 empty, so on and so forth. Your 4 is also empty. Now in the add edge function, you added the vertices. Now we need to come up and maintain something known as adjacency list, right? So maintain adjacency list. So how are you gonna do that, guys? Now, since it's an undirected graph, right? So your vertex 1 should have the vertex 2 and vertex 2 should have the vertex 1. So how are you gonna do that? What should I write and how I should do that? Can I get acknowledgements from all of you? What should I write here? So I have these vertices. Exactly, Gurlivlin. So you need to come up and say self dot vertices of edge dot vertex 1 assign edge dot not assign. So you need to come up and say dot append edge dot vertex 2. And the other way around, it's gonna be in the vertex 2 you add the vertex 1. So this is how we are trying to put up this adjacency list. So now when you run this program, so we get to see the adjacency list for this vertex 0. So let us confirm here. So vertex 0 has this guy 1, 2, 3, and 4. 1 has 0 and 2. Then this 2 has 0, 1, 3. Then we got 0, 2, 4, and last one 0, 3. But I see in the adjacency list, I have this weight as well. So how I will maintain and manage the weight? So in order to do that, I'm going to say edge dot vertex comma edge dot weight, and you append the data as a tuple. Same way, edge dot vertex 1 comma edge dot weight, you append the data as tuple. So maintain the data in list as tuple where we have your adjacent vertex and weight. So now let's run this program and see what's going to happen for us. So guys, let's try to match this undirected graph once again, the weighted graph. So the 0 has 1, 4, 2, 4, 3, 6, 4, 6. Then your 1 got the 0, 4, 2, 2. Right? And lastly, so on and so forth, your fourth vertex got 0, 6, and 3, 9. So if you want to really print it in this manner, so if you want to come up and print down the data in this manner, so what we can do is we can just skip this part. We can say print your key, right? And thereafter, I'm just gonna print this column, and I'm gonna say and assign a space. So let's see now how the program will print the data for us. So here we are now. So 0, 1, 2, 3, and 4. So guys, can I get a smiley from all of you? Is this part clear to everyone? What is a undirected weighted graph? This is not that challenging, right? At the same time, correct? So it's not that difficult. So coming here in your undirected weighted graph, it is supposed to be a directed or weighted. So how are you gonna deal with it? So let us say you have this directed weighted graph, right? So in the directed weighted graph, so you are maintaining this edge list, right? And let us try to even write this directed weighted graph and see how it can be solved. So just give me a moment. I'll just pull this screenshot into the pie chart for your reference purpose. So we got the next one as directed weighted graph. And this guy is not that challenging to be maintained. We can write the program in the same program. We can try to adjust in the same program. So while adding an edge, you need to specify is directed, right? So this value is by default, let's say false. I'm just going to put up this guy called is directed. So in case it is directed, so what we are not supposed to be considered, what we have not to consider, right? So if not is directed, then you need to come up and maintain the vertex 2 at the same time if it is not directed, right? And same way, we need to come up and say if not is directed. Okay, so what I'm gonna do is I'm gonna make this as by default true. Just give me a moment. Let's say this is false, and yes, that's how it's gonna work, right? Now, in case it is directed, so the answer is false. So not of false is going to be made true. So by default, this graph add edge function shall work for undirected graph, right? And for directed graph, we must set is directed to true. So the moment you will set is directed to true, it's gonna work as a directed graph. So this was how we created a directed graph. I mean undirected graph. So this was my undirected graph. So let us try to write directed graph here. And in the directed graph, we got this edge list, right? So 0 to 1, 0 to 2. So I'll just quickly, write these edges. All right, so this is what we got. And let's say the weights, it can be any random weights, but let us try to have the same part here. So here we are with these 7 edges, right? So 0 to 6, you got these 7 edges, and now these are all directed for us, correct? So 0 is connected to 1, but 1 is not connected to 0, right? The vice versa is not true for us. So in this session number 33, we are going to add the same edges in the same way, but this time when you are adding the edge, you just ensure that you are passing this guy called is directed as true, right? So we pass true for directed graph. The rest everything remains the same. So we run the program now, and let us see how directed graph adjacency list is going to be maintained. So 0 got 1 and 99, 250. 1 got 250, 350, 450. Then 2 got 399 and 3 got 475. You don't have anything with respect to your 4. So can I get a smiley from all of you? Are we clear with how this graph should be working for us? Now, in case you want to have all of your vertices, right? Now, this is a use case. If you see in our program, this vertex 4 is not getting printed, right? Because vertex 4 has no edge to the other node. So I can disable this vertices being added at any cost here and there, right? So let's run this program. Now you see this 4 coming up with an empty list. So exactly as in what we got as in this adjacency list. So the way you got this list, guys, write this adjacency matrix yourself, right? So I'm just going to say this function print this graph, right? So here we are printing this adjacency list for us. So write your basic program, your code to print matrix, right? So try to come up and print this matrix, right, for both your directed and undirected graphs. A smiley once again awaited as an acknowledgement from all of you. I hope this part is clear. What are directed, weighted, and undirected weighted graphs? If we are good to go, we'll proceed towards Google Maps implementation as an example with a case study, right? We'll see how Google Maps graph data structure can be implemented. All right, so let's now write one more Python file. This goes like your session number 33A. So we'll come up and try to say that there is a class called Google Map. Right, Google Map is going to be a graph for us, right? It's gonna be more or less, if you want, you can consider directions or you can consider no directions, right? We'll try to write the code in both the ways. So directed slash undirected weighted graph. So we are going to implement this directed and undirected weighted graph. So the use case for us is going to be Google Maps, right? So this graph will work in both the ways, but Google Map is basically kind of a collection of something known as location and a path associated to that location, right? So I'm going to define this term called location. I'll make this class as location, and let's say a class called path as another structure, right? So these are the three objects which we are going to consider to write a Google Map. Now, when I'm writing this Google Map, I have this location, I have this path, but what exactly location will have and what exactly the path will have, that we have to consider, right? So for a location, let us define one constructor. So location is made with latitude, longitude, right? So there is a latitude and a longitude when it comes to a location. So other than the lat long, there may be, you can say, something known as your address line, correct? So there may be an address line. There may be some business name, right? There may be other several options, but I'm just considering something very basic: latitude, longitude, and address line, right? So a location can have several attributes, as in whatever needed. Now for this, I will request that you can consider what exactly a location is. It can be a business place, it can be a medical shop, it can be a grocery store. So these locations can be further divided or categorized, right? So you can write an inheritance model where location may be of several types. But this is one generalized location which I am taking as an example. So you say self dot, let's define these, latitude is latitude, then self dot longitude is longitude, then address line as address line, correct? And if you want to say get the location details, so we are going to just say return back. So this is latitude comma longitude comma the address line, right? So dot format self dot latitude, self dot longitude, and self dot address line. So this is what a location represent, right? And when I say, so this is a location or a place, right? So terminology can change. We are talking about location or place in map. So if you want, you can name it as place. So typically a location means latitude and longitude, and a place means that it's gonna have address line, business name, pin code, etc. and etc., right? It may further have objects like address, right, where we can have address line 1 2, pin code, zip code, this that, etc., etc. So I'm not doing that perfect oops here, but I'm trying to kind of correlate what can be what. Now, when I'm saying a path, so path is going to be a collection of location, right? And I'm considering this location. So for our graph data structure, location is kind of node, right? Slash vertex. So this is going to be a node or a vertex in our graph data structure. So what is this path? Path is going to be edge. So path is kind of edge, where edge will be location 1, location 2, and the weight. So you define this class path. In the constructor of this fellow, I'm going to take location 1, location 2, and this weight. So weight over here can be referred to as distance. So let us say self dot location 1 is equal to location 1. Then so on and so forth. We have this location 2 and the distance. So distance between location 1 and location 2. So guys, on this particular path, right? So let us assume that there is something known as traffic. So what is the severity of traffic on this path, right? So let's assume 1 means I'm just considering 1 as free flow. So 2 as, let's say, moderate traffic, and 1 as jam, right? Sorry, 3 as jam. So you can kind of maintain this traffic attribute on this particular path. So this attribute may be updated again and again. So guys, can I get a smiley here? Are we all good to go? What we have done so far? These two objects are clear to everyone. So before I write my Google Map code, so I'll very quickly write some locations and then some paths, right? So let us come here and say a location 1, which is a location. So there is some address line 1. Let's say this is some Redwood Shores. So we have few locations here which I'm going to just write down. So guys, these are just random numbers which I'm considering, right? All right. So let's say Redwood Shore. So we got Country Homes, Christine Magnum. Let's say Bayside. The last one is, let's say, Castle Woods. Some areas, right? Some locations I have taken up, right? So these are a few locations, and I'm going to consider certain paths here. So let's say there is a path 1, which is going to be your location 1 connected to location 2, right? With a distance of, let's say, 10. So path 2, 3, 4, and 5. Location 1 connected to location 3 with a distance of, let's say, 12. Then location 2 connected to location 3 with a distance of, let's say, 16. Location 3 connected to location 4 with a distance of 3. And location 4 connected to location number 5 with a distance of, let's say, 19. Let's say this 30. So these are the 5 paths, right? For my 5 different locations, I got these 5 different paths. So one is connected to 2, one is connected to 3, right? So I can even say one is now let's come here and define a path 6. That 4 is not 4. So we'll have one more path here only. So one is also connected to, let's say, 4. So 1, 2, 3, 4, 5, and 6. So this is what I have the structure as in my paths, right? So locations and the paths. So path for me is going to be an edge, right? So I have this list of paths. So path 1, then the 2, then the 3, 4, this 5, and the 6. So 6 paths, but every path for us is weighted as in this distance. You can assume the distance in kilometers or in miles, right? So next is I need to write my Google Maps. So for that I follow the same pattern here. So let me copy this part. So the previous discussion, right? So the very first thing is Google Map is going to have vertices. So you can change the terminology, right? So Google Map is going to have locations. So that's the change in terminology for us here. So when I say add edge, basically you are going to add the path, right? So you're going to take path as input rather than the edge. So if your path dot location one not in self dot locations, so in the self dot locations you add location one in the path. So you got a path dot location one as one key in the dictionary, and the adjacent locations to this location is an empty list for us. Same way, you got this another part. So I'm just gonna very quickly write this. So location 2, so you add this location 2. Now if you are considering this to be your directed or undirected graph, it's gonna work in the same way on the is directed parameter, right? So you just have these locations and this edge as your path, and instead of this vertex 1 you got this location 1, location 2, location 2, and location 1, and this weight is basically distance for us. You see how beautifully the same code is being used for us, right? So let's say, so this is add path, so print Google Map. So number of locations, self dot locations. So locations dot keys, right? So you're going to maintain this adjacency list. So you are printing down this adjacency list. But now if you're going to just print this self dot location of key, it's gonna give you the hash codes, right? So let us try to run this program first of all. So I'll just do the rest of the job. So just give me a moment. So I'm gonna use the same terminologies, right? So for path in paths, path dot so okay, so we'll define one more function here. So let's see what is this function. So I'll say define get path details. So in the path details, you got this location 1, location 2, and the distance, right? So guys, I'm just going to return one string. In this string, so this is how you are going to come up and define this string here. So dot format. So I'm just going to say this location one self dot location one dot address line to this self dot distance, and the last one is self dot location 2 dot address line. So I'm returning this path where you write the address line, then the distance, then the address line too, right? So you can use other attributes at the same time in the location. That's like your lat long if you want, right? It's up to you. So coming here, so whenever you will print the key here, so printing the key means that you're trying to print this location, right? It's gonna give you a hash code. So you are printing this location. When you are printing this guy called key, it's gonna give you nothing but the hash code, right? So the better is that you print down this location details. So it will print down this entire lat long and the address line. Okay. So I'm just going to come here and say, so this return statement, I'm just going to make it in this manner. So this followed by this comma this, right? So you have the, first of all we'll get this address line, and then we'll have this latitude and longitude. So coming here, I will not just say print me key, I will say print me key dot get the location details. All right, so you get the location details. Once you get the location details, thereafter we'll print down anything else. But let's see what we have this when we say print me the location details. So let's say graph is a Google map, and I'll say graph dot print of the Google map. So printing of a Google map right before, and for path in the paths, right? So graph dot add the path. So I'm making this to go as true, which means it's gonna be a bi-directional graph. So lastly, let's say graph dot print the Google map. So let me try to run this code. Okay, so I think we did something here and there. So just give me a moment. Sorry, my bad. So for path, in paths, get the, I didn't created this path. Yeah, we did that. So get the path details. So here we go. So let's see first of all. So in my graph, right, what you can see is these different paths, right? So Redwood Shores connected to country homes, so on and so forth, right? So initially the locations were 0, but when you added the locations, right, in your map, so they became 5. So these are the 5 locations: Redwood Shores, Country Homes, Pristine Magnum, Bayside, and Castlewoods, with their lat long coming as this comma separated value. Now we want to print their adjacent locations. If you want to print their adjacent locations, right? So coming here, you say self dot locations of key, but I'm gonna do it in some another way. So I'll use this print, and thereafter I will say print adjacent locations. So print me locations of key. This is not going to work as in, because when you are iterating, you get this locations of key as your list, right? So this time I'm going to say for location in self dot locations of key, and print us location dot get the location details. So finally, once you are done with this loop, we'll do an empty print line. So first of all, you print the location, then you print the adjacent locations, and then you print let's say this delimiter, right, in the end, and thereafter I'll have an empty print. Now let's run this program. Okay, so we did one small mistake here, which we were doing in our previous part here. So you are having this. So I'll not add the distance as in tuple. So I'll just add this location 2 only, right? Will not append the distance because distance is now available as a part of your object only. So you can eliminate that. Let's run the code. So let's now see what we got. So the first is your this country homes. Even before, yeah, the country homes. Let me check from where did it start. So I'll just give a small. So this is like you are printing this Google map. So I'll just say a print here. Printing Google map with adjacent locations. Right. So we'll just have this one basic print statement so as we can isolate our previous, we can discriminate between our previous locations. So printing Google map with adjacent locations. Number of locations are 5. These are the 5 locations, right? And thereafter you started with this country homes, and the adjacent location is this. Let us see, location 1. I think this loop is iterating, so just give me one more moment here. So 1 to 2 is this. So one was guys, I'm just gonna consider one small change here. I mean to say, for our better understanding, I'm just putting up these numbers here, right? So that we can just have a better understanding on our outputs, because textually it's gonna get confusing for us. All right, so here we are. So this is our very first location, Redwood Shores, having 3 adjacent locations. So location 1, location 2, location 1, location 3, location 1, location 4, right? And location 2 country homes having this location 3, 3 having 4, 4 having 5, right? And 5 has none. So this is how you are trying to maintain your adjacency list, right? And along with the locations. So if you want to come up and show the distances, you can even show that. So as of now, this is just the location, right? So I'm printing this location, but what is the distance between this location to that location? If you want, you can use this parameter distance. It's available in your path object, right? And you can show that as well. So let me put this code over the chat. So you guys please review the same and let me know if you are good to go with Google Map implementation as your graph data structure. Guys, I hope you have enjoyed this part of session, how we can code a Google Map. A very quick introduction to graph data structure, right? So we understood, we know how the Facebook was created as in your graph data structure, Instagram as in a directed graph where you have the followers following. We don't have a bi-directional structure. In Google Map, you have a bi-directional structure, but if you want, you can limit the directions by making true to false. So this is not directed graph, I think, right? If you ignore this, so this becomes undirected graph. So when you run the program here, so here now it is an undirected graph, right? So Redwood Shores, then country homes will also have Redwood Shores, right? So it's a vice versa, the other way around. So it depends upon you how you wanna add the data, right? So this is your undirected graph structure. And if you will add true, this becomes directed, right? So both ways, it's up to you how you're gonna maintain it. So can I get a smiley from all of you? All right, guys. So this is what is your data structure called graph, right? And this will be all for the day. And the next part of our discussion shall be the algorithms, how we can find the shortest distance. So we're gonna work on minimum spanning trees. And once that is finished, so we have a try data structure coming up, right? And lastly, we have dynamic programming. So you can consider one more week. We will be coding much better things in our upcoming times. So stay connected, and I would request all of you to be regular. So this is going to be a 9 a.m. session every day. So lastly, if we are clear and if we are good to go, please raise a smiley so that we can close the session. And yes, I'm going to push this code on the GitHub. Please do also practice the same. So thank you guys. We'll meet now on Monday. 9 a.m. will be the batch timing. So that would be all. Thank you so very much, guys. Happy coding. Thank you. And do write your assignments.